So, derive a formula in terms of OR and theta radians for the area of the minor segment under the chord BC. So, this is what we need to get a formula for. This bit here that they've shaded in, I'll shade it in again. Okay. Now, so you need to know how to find the area of a sector of a circle using radians. So the formula for that is a half r squared by your angle, which in this case is theta. That will give us the area of the full sector. After we do that, we have to take away the area of our little triangle. So now we need to find the area of this bit. When we do that, we'll be left with the highlighted bit. So the area of a triangle, well, using trigonometry, it's a half AB sine C. So make that bigger again. A half A, which is OR, B, which is OR, and the angle between them, sine theta, that we don't know. So you have a half OR squared theta minus a half OR squared sine theta. So you can factor out the half OR squared to be left with theta minus sine theta. And that there is, well, that there is this bit here. Okay, so the next part of the question, it says, hence find the ratio of the area of the major segment. So major segment would be everything else. That would include this here. So we've got to find the ratio of the blue to the yellow. Find the ratio of the major segment to the area of the minor segment, subtended by an angle. So now we're told that this angle is 90 degrees. But we'll stick with using it with radians here, it's probably handier. This angle here was 90 degrees. What's the ratio of the blue to the yellow? Okay, so what is the area of the major segment? Well, the area of the major segment is, it's the area of a circle, so pi r squared minus the minor segment, which of course is minus all of this here, minus a half r squared theta minus sine theta. And before we go any further, we might as well work out what the minor segment is given an angle of pi over 2. So what would a half r squared by pi over 2 minus sine pi over 2? So half r squared pi over 2. Now the sine of 90 is equal to 1, so you've got minus 1. So this is what we've got to use and to substitute into our formula over here. So we've got pi r squared minus a half r squared pi over 2 minus 1. Now, just move this up a bit, I can get rid of that. So, yeah, so that there is the area of the major segment. So we're asked to find the ratio between the two. So probably just keep working with this. Now, this is r squared over 2. I'm going to multiply that in. We're going to get r squared pi over 4, and we're going to get plus r squared over 2. Now, tidy up what you can. So you've got pi r squared and you've got r squared pi. So they're the same thing. So this minus a quarter will give us 3/4. So we've got 3/4 pi r squared. Hope that makes sense to people. That minus that gives you this. Plus r squared over 2. We can factor out our r squared. We can factor out r squared over 2 actually. Oops. So we factor out r squared over 2. Well, we'll just factor out the r squared. We're left with 3/4 pi plus a half. So that there is the area of the major segment. So what is the ratio between that and the area of the minor segment? So we bring it back, we can look at the area of the minor segment, and when it's 90 degrees, that there was the area of the minor segment when it was 90 degrees. So that's what we have to compare. So the major to the minor. The major is r squared into 3/4 pi plus a half. And the minor is r squared over 2 into pi over 2 minus 1. How do we compare those? Because they don't look anything like each other at the moment. Well, the orth squares can be took out of them. Right? So if we put one over the other, what would cancel? So they would cancel. So we've got 3/4 pi plus a half. And over here we have a half. I'm going to multiply the half in. You're going to get pi over 4 minus a half. Let's get them with common denominators. So 4 is the common denominator here. 4 into 4 goes 1, so you got 3 pi plus 2 into 4 goes twice. 2 by 1 is 2. And over here, over 4, 4 into 4 goes 1, so you're getting pi minus 2 into 4 goes twice. So we can compare them as 3 pi plus 2 to pi minus 2. Yeah, not easy, I'd say now. Certainly wouldn't like to be doing that in an exam. Probably should have done it before I went to make the video of it, but there's a lot going on there. Doable, but still, there's a fair bit going on.